This is the second video for geometry. In the first video, we talked about TEKS 4.6a through TEKS 4.6d, and we really talked about these TEKS being geometry vocabulary. And so there's a lot of definitions, a lot of words that students need to know, a lot of geometric figures they have to know by sight, be able to identify them and classify them. We talked about how it's really more than that. Students don't just need to look at the shape and be able to identify. They also have to know the definitions of the shapes or figures, and they also have to be able to create those figures if given the name of the figure or the attribute of the figure. So it is really a deep understanding of the geometry vocabulary. So I encourage you to make sure that you are continually having students do geometry vocabulary activities and including them in your stations for the rest of the year. Today's video is going to be about TEKS 4.7a through 4.7e. And this is your measuring angles TEKS. We're going to start out with 4.7a and 4.7b, and those two TEKS really are the background for students of why we measure a circle in 360 degrees, and also letting students know that an angle is part of a circle. It's been cut out of a circle, okay? So to help students kind of figure this out, we're going to start with something we're very familiar with. We're going to start with a square. And we're going to talk to students about what is a square. They know what it is. It has 4 right angles, equal sides, so forth. Then either you or the students or both of you, I think it's very powerful if the students do it as well. You're going to tell students to take the corners of the square and you're going to cut them off kind of in a curved way. It doesn't have to be perfect. It really doesn't, because they're going to get the gist of it. I know mine never come out 100% perfect. Alright, so this part of the Post-it note I'm getting rid of, and I'm only caring about the 4 90-degree angles that I cut out or tore off. Then you're going to have students put these 4 90-degree angles together. As I said, it doesn't have to be perfect. They don't have to be all smushed all together either. You can leave them like that. And I'm going to ask students, what do they see? What shape did we now create? And it's not perfect, but I think we all can see that this is a circle. And that if I was to take this 90 degrees out, this is an angle. This is one part of a circle that has been removed, and I can measure that part of a circle to be 90 degrees, okay? So we're going to talk to students about, well, what is the whole circle? One whole rotation, no matter one whole rotation from this point all the way around back to this point is 360 degrees. And we prove that to them. What is 90 plus 90 plus 90 plus 90? It's 360 degrees. We make sure we talk to students about, we measure angles in degrees. This is the degree symbol. So we do this type of activity saying that one whole rotation from here all the way around is 360 degrees, okay? And so we've shown them through that, all right? So then we can do other activities like this to help them, and we can practice measuring other types of angles. And we can do that with pattern blocks, okay? I can say, well, what if I put, see if I can get this right. There we go. What if I put these 3 together? From here to here is one whole rotation. It's a circle. So what would the measure of these angles be? They'd all be the same thing. How could I figure that out? Well, they don't know how to divide yet, so you can either use a calculator, which is okay, but you're just trying to get them to understand that these three angles are one part of the 360 degrees, right? So you could do the division for them, or as I said, you can use a calculator, have them do it with a calculator with a partner, so we know that's 120 degrees. I don't know, can you do the math? So each one of these angles, and they could draw it. This angle, right, is 300 or 120 degrees. So I know this angle is 120 degrees, this angle is 120 degrees. So this circle is made up of 3 120-degree angles, okay? And you can continue to do that with other pattern blocks. What you need to help students kind of see this, and they're pretty easy to make, but you can make a hinged mirror. And this is just cardstock with the reflective coating on top that you can buy in a roll. And what's so great about this is that you can use pattern blocks or any type of manipulative, and you can put the pattern block in that hinged mirror. See if I can get this to go up so you can see it. Here we go. And, oh, wrong, there you go. And you could see that angle there. I would need, let's see. I like this one better. So if I want to measure this angle here, I don't know if you can see that, but I would need 6 of this angle to create the circle, one rotation around. So I could then say 360 divided by 6 and find that measure of this angle here, right? So it's a fun little activity for students. They're not actually measuring the angle itself with a protractor or anything like that, but they are learning that that one rotation of a circle is 360 degrees, and that the endpoint's at the middle, and that any piece that I cut out of that circle, I'm measuring it's one part of that 360 degrees, okay? So that's the purpose of those first 2 teaks, is really for students to understand that a circle does have 360 degrees. Then we can bring out this lovely thing, and we could show them that if I have 2 of these, that's 180 degrees. And that if I had 2 of these and put 2 of these together, look what I've created. That once again, a circle is, what's 180 plus 180? It's 360 degrees. And so when I'm using a protractor is, oh, I have it upside down. A protractor is half of a circle, and so it is 180 degrees, and that is our straight angle, right? And up here is our 90 degrees, and so you can talk to students about what a protractor is, and that it gives me a way to measure a cutout piece of a circle, cutout angle of a circle. Allow students the opportunity to actually use protractors. I've heard teachers say, well, they don't get to use protractors on the test, so we're not using them, we're just going to do the paper ones. That's like saying we're doing place value on the test, but we're not going to use base 10 blocks. So we're doing addition on the test, but we can't use base 10 blocks, so I'm not going to teach them the reason behind base 10. They need hands-on experiences with protractors. So when they get to the abstract pictorial or the pictorial model of protractors on a test, that they understand what a protractor is. So whatever protractor they're given on the test, they can read that interval, they can use it, and they have background schema to what a protractor is. They need to hands-on manipulate angles. So you're going to teach them what a protractor is and all the vocabulary, the terms, inner, outer scale, all of that. And then students are going to start practicing measuring angles. So you know they put the center mark, and this isn't a great one, but they put the center mark on the end point. They put this, I call this my 0 line, on one of the rays, and then they determine whether they're going to use the inner outer scale. I always say this is my 0 mark. Kids get confused about inner outer scale. Well, if this is 0, is my next number going to be 170 or is it going to be 10? This is going up by intervals of 10. So it's going to be 10. So on this one I use the inner circle. I go around, and because my line is so fat, because I'm using a marker, I can't really tell the exact degree here, but I know it's in between 115 and 120 degrees. So students need practice actually determining this is a 0 mark and doing their protractor, and then they can measure it this way too. Well, so if this is the 0 mark, I'm using the outer circle because the next number is 10, and I get about the same thing. Looks like, well, now I can see that it's more towards 119 and 121. So students need to be able to manipulate to see, it doesn't matter which way my angle is tilted or turned, it's still going to be the same amount. Students also need practice measuring angles like this. So what if I don't have it on the 0 mark? It makes it more difficult to do, but can I do it? Yes, and on this type I can pick either the inner or outer scale to use. And so you talk to students about that, and they can either do their jumps on the outer scale to get to where they need to be, or they can do their subtraction. What is this ray pointing to? What is this one pointing to? And the difference is the measure of that angle, okay? So they do need hands-on practice with a protractor measuring angles. After they measure angles, you're going to talk to them about drawing a specific angle. Once again, that is, okay, I want you to draw a 50-degree angle. So they draw their 0 line ray, right? They put it on the center mark. I want to draw a 50-degree angle. Put a dot, and so forth. Okay? They have to use protractors to do that. They cannot do that paper. So they need to be using hands-on protractors to draw a specific angle. All right, so just wanted to show you a couple of items from the STAR test, the release test, the one we did last year for our release test or simulation. So this is the type of question they can get: which angle is closest to 30? The first thing I would teach kids to do too before they actually measure an angle for reasonableness is to have them determine what type of angle it is. I can look at this one and know that it's an obtuse angle, so it's not close to 30 degrees because an obtuse angle is greater than 90. This is an acute angle, so it may be 30 degrees. This one's an obtuse angle again, so G and H are out. F, I can't determine it, but just what it looks like an acute angle. So F and H are the only ones that I actually have to go and read the protractor to determine that angle measure. You may have one as simple as this, which is just, do this measure to the nearest degree, okay? And then you get into, once you've used the protractor for a while, the last thing that you talk to students about is the concept of, what if I break one angle into two? And this is finding the measure of an unknown angle when it's, they call them adjacent angles, when they're right next to each other. So I know this angle has a measure of 41 degrees, and I know NLP is a right angle, so what is the measure of the whole angle? So I would have to do 90 plus 41. Sometimes they'll give you the measure of this one and give you the total measure of the whole angle and ask you what this measure is. So it just determines on the question, but they need to have practice with finding either the whole angle measure based on what they know about the two angles, or finding the missing angles based on the whole angle measure and one of the angles. All right, I think that's it for measuring angles. Please take a look at the instructional talk notes page. There's a lot of information there, a lot of reminders about how to teach students to measure using a protractor. Please let me know if you have any questions, and we'll see you in the next video.